Good day to you, sir. We are the Group 4, and today we are going to present our presentation, and our topic is all about positioning and navigation systems. And our group members are Lemon Jr. Diolito, Iskander Zaid, Gabisa Gale Elijah, and Rinaldo B. Esmas Jr. In our course outcome, solve problems and to learn the ability to determine and calculate the positioning and navigation system. In our learning outcome, at the end of the session, the student shall be able to determine the positioning and navigation systems. The importance of the topic. Positioning is the ability to determine the geographic location of a person, object, or signal. Navigation is the ability to calculate a road to a desired position from a current position. In other words, it is ability to calculate the path from point A to point B. Here in examples 2 and 3, if the variation is 3 degrees east and deviation is 2 degrees east, how do we calculate the compass error? So here's the solution. So we get the variation deviation, which is 3 degrees east, and the deviation is 2 degrees east. So by getting the compass error, we need to add the variation and deviation, and we copy the solution, which is the 3 degrees east and 2 degrees east, and we add those two. We got the answer of 5 degrees east. Now, if the variation is 4 degrees west and the deviation is 2 degrees east, how do we calculate the compass error? In solution, variation 4 degrees west deviation equals 2 degrees east compass error equals negative 4 plus 2, we get 2 degrees west. Now, if the variation is 4 degrees west and the deviation is 2 degrees east, how do we calculate the compass error? So here in the solution, the variation is 4 degrees west, the deviation is 2 degrees east, the compass error is negative 4 plus 2 equals 2 degrees west. So the next reporter will continue the solution and provide more information. That will be all. Thank you.
So, good day. So, by the way, I'm Cadet Gil Elijah Gabisay. So, I'm here to tackle about the calculating positioning and navigation systems, explaining the deviation, shape-specific error, so additive effects of compass errors, measuring deviations, and compensations, and lastly, the computing compass corrections. So, first, the examples for the 4 and 5. So if the course bearing is equals to 52 degrees course, so the variations 4 degrees west and the deviation is equals to 1 degrees east. So calculate the true bearing. So this is the solution on how to get the true bearing. So first, let's get the variation. So variation is equals to 4 degrees west and the deviation is equals to 1 degrees east. So first we must get the compass error. So the compass error is equals to 3 degrees west because 4 degrees west from variation, 1 degrees east for deviation, so minus because of its opposite direction. So the compass error is equals to 3 degrees west. So the course bearing is equals to 0.52 degrees course, so minus 2 course error. So in order to get the true bearing, so the true bearing is equals to 0.49 degrees. So next, so if the compass bearing is 0.28 degrees course and the true bearing is 0.25 degrees true, so find the compass error. So this is how to get the compass error. So solution, so true bearing is equals to 0.25 degrees true and the course bearing is equals to 0.028 degrees course. So the compass error is equals to 0.03 degrees west. So note, so if C is less than T, the error is east, and if C is greater than T is west. So deviation, shape-specific error. So due to onboard magnetic influence, so magnetic items to which magnets are attracted. So wires carrying DC electrical current. So to reduce effects as much as possible, keep compass away from influences and twist nearby DC wire pairs. So usually can't eliminate them all. So this is the illustration of the additive effect of compass errors. So the the violet one, the darker violet one is the desired true heading. So the magenta is the compass heading must be adjusted to 0 to 0 degrees to compensate. And the darker green one is the additional error due to 005 degrees west deviation. And the lighter one of green is the error due to 015 degrees west variations. So measuring deviation yourself. So by using the deviation table or curve, we can obtain the deviation value of a specific compass course. So first, you have to know how to do some compass calculations. So compensations. So deviations often greater than 10 degrees. So special magnets or compensators installed in compasses to reduce error. So most compasses comes with instructions. So can still have significant deviations error after compensations. So this is on how to get the computing compass corrections. So it indicates the plus west through heading. Next is the variation on charts, magnetic headings, deviations, and compass course. So true heading is 000. So variation on chart is 015 west. The magnetic heading is 015 and the deviation is 005 west. And the compass course is 020. And that's all.
Good morning everyone, I am Cadet Iskandar M, and today I'm going to discuss the worldwide variation. So, worldwide variation, first is the isogonic chart. It illustrates magnetic variation. 1995. So, as you can see in the picture below, this is the main field geomagnetism. So, there are different color in different degrees, such as negative 30 degree, 20 degree to 30 degree to 20 degree, 20 degree to 10 degree. So it is the magnetic declaration, then model for 1995.0. And next is the swinging ship. First, process of measuring residual deviation error after compensation. Next, usually determined in 50 degree to 30 degree heading increments, recorded in form of deviation table and port compass adjuster can provide service, or you can do it yourself. Back to measuring deviation. For each 15 degree to 30 degree, you need to first know exactly what direction of the magnetic of your boat is pointed. Compare with compass reading, compute deviation, key to puzzle, and second key to puzzle is knowing exactly what direction you're headed. There are several ways. Example way to know your heading. In calm water with minimal current, remaining in vicinity of ATON, record both compass heading and relative bearing every 15 degree to 30 degree. Compute deviation for each heading. So as you can see, you can track the closest variable ATON to know your heading, if that was exactly your heading, and your means to take relative bearing, if it's correct. Next is the way to know your heading also. So, first is mounted parallel to vessel keel with all around view. Then 0 degree aligned with keel. Align target in sight. Read relative bearing on scale. So you can, as we can see this picture, you can use it to align target in sight, such as if there's a mountain or a boy and any fixed object. Next is electronic steering compasses. Future automated division, elimination. So this is the example in the picture, the electronic steering compasses. Then, next, local magnetic disturbance. First, compass still seems wrong. It's in some location there are local magnetic disturbance with that can affect your compass. Don't worry because it's often noted on chart if there are any location of magnetic disturbance.
So all this sounds complex. All this sound complex. Perhaps, but best solution is practice, practice, practice. Shipboard compasses. The gyro compass has 3 axes: the spin axis, the torch axis, and the precision axis. As a centrifugal force of the Earth rotation, or what we call tangential velocity, acts upon the gyro, the torch and precision axis will act and keep the spin axis oriented to a terrestrial meridian. Gyro compass. The gyro compass has a several advantage over the magnetic compass because it seeks true or geographic meridian instead of magnetic meridian, and it can be used near the Earth's magnetic poles, where the magnetic compass is useless. It is not affected by surrounding material, and its signal can be fed into internal navigation system, automatic and steering system, and fire control system. Being a complicated electronic instrument, the gyro compass has some disadvantage, and it requires a constant source of electrical power and is sensitive to power fluctuations, and it requires periodic maintenance by qualified technicians. Methods of determining compass error. So, although the gyro compass is a very accurate instrument and normally has a very small error associated with its reading, or less than 1.10 to 2.0, and the navigators it required to determine gyro error at least once a day. Gyro compass error, like magnetic compass error, is measured in degrees east or west. The gyro compass bearing is higher than the actual bearing, the error is west. And if the gyro compass bearing is lower than the actual bearing, the error is east. And these are the illustration of the gyro compass bearing. And that's all. Thank you.